to Enots Engineering. I'm Alan. In today's video we continue with part 2 of making a thread dial with the Boxford lathe. This is the finished item. The 2 gears and the top dial will be on the internet, and it takes about an hour and a quarter to 3D print each part. The top dial, when it's printed, has some scaffolding around the bottoms which you just need to break off, and when the gears are printed they come off like this. All you need to do is break this flash off, and as I said before, put a square file through the hole just to sharpen the corners up on the hole. There are 2 gears and a top dial. The one gear has 20 teeth and the other gear has 21 teeth. I've put the web address on the video description page, and also if you need to get the Boxford information about which dial to use for which thread, if you go onto Google and put Boxford thread dial and then click images, you'll see the plate that is fixed to the lathe that has all the different threads and which gear you use and which engagement mark you use, whether it be A, B, C, D or E. So let's go into the workshop and see how we do it. Just relieved the edge of the tube that we made, and that's so that if this is the lead screw, that will go down there, engage in the gear and miss the tube. Got some backwards and forwards adjustment on that, so that's about where the lead screw will sit on the gear. Look from that side, it's just below the face at the bottom, and it comes up the side just to give clearance so that the gear touches the lead screw and not this aluminium side. So what I need to do now is make the method of fixing this to the lathe. This is the hole for the thread dial. This is how I found the centre. I just fitted a piece of 3/8 bar with a little pip on the end. So what I did was put the bar in, lock the bar up, engage the gear at the bottom with the lead screw, check from the side that it's virtually in the middle of the gear, and then just rotate this up, and this point on here, scratch the line on the side of the bar, and that's where I drilled and tapped the hole. This one I've done on centre line. That's how I got the distance from the centre of the gear to the centre of the pin. Put this in the milling machine vise with this face 90 degrees to the table, and I'm going to drill a hole through the sides and tap it M8. Now I've turned the body round 190 degrees. I'm just putting a hole in the other side. down to the other end. This little hole I'm drilling in here is to get oil into it. So here I'm drilling a 2.5mm hole. Countersink the hole to give me a lead for the oil can. Here I want to drill a 5mm hole for an M6 thread. So this hole is to hold the gear that's not being used. This hole is to put oil in, and you can see it's come out just inside. I've just put a 3/8 of an inch rod in the chuck, and I want to turn this end down to 8mm and thread it 8mm for the side at the body of the thread dial. Needs to go down about 10mm. So now I'll put a lead on the beginning of this. M8 die. And while it's in the chuck, it's easier to use the chuck to hold the rod to screw it in. This is the finished spindle. An 8mm diameter shaft, 6mm square on this end with a 4mm thread down the middle, 6mm square on this end and a M6 thread. The body, in this end there's 11mm bush with an 8mm hole. This is 15.5mm by 5mm deep, and this end, this bore's 23mm by 15mm deep with another bush. On the side we have a rod. This holds the parts of the lathe. It's a 3/8 diameter bar with an M8 thread on the end. The other side we've just drilled a hole through with an M6 thread and just flatten the face, and that's to hold the spare gear. Here is a 2.5mm hole that's been countersunk, which goes through just above the bush so that you can put oil in there or go into the bush, run down to the other bush and lubricate the part. On the top here I've riveted on this piece of aluminium, and all that's for is to give you the mark to engage and disengage the lead screw. So that's the body. We also made the brass nut that goes on the end of the spindle, just a simple brass hand nut. And on the other end of the spindle is just this threaded screw with a washer. Then the plastic parts that you can get off the internet. The top dial, which has a 6mm square hole, a 20 tooth gear which has got 20 marked on it, a 21 tooth gear which is marked on it. Both of these have a hole, square hole, 6mm. All you have to do with the plastic parts is to take the flash off and file out the hole just to make the corners sharp. Not much, it doesn't need to be a tight fit on the spindle because the square stops it rotating. So to assemble it, we put the dial on the short end of the spindle. Just pushes on, and the screw in the top and all that does is stops the dial coming off. That then goes through the body. On the bottom is the select which gear you need. This is a 20 tooth one. That just drops on there. There's no interference fits, it just goes on. And this just screws down, loose fit on there, and you need a little bit of play between the gear and the top. If you tighten this up too tight, you're just clamping the gear to the shaft and locking the thing up. So you do need a bit of play just to give you the movement, free movement. And that's the finished unit. The hole in the side there is for the spare gear to go on. Just use a cap head or a domed head. That screws on there, just so you don't lose the gear. So now we'll go over to the lathe and see how it works. Just an 8mm thread on a 3/8 bar. 3/8 bar fits this hole, it's already on your lathe. Put that onto the you can tighten that up, and then on the other side I put the M6 thread to hold the gear. So when I put that away, it's all together, and that fits into there. Make sure on the end of your grub screw you have a little brass pad, so you're not digging the grub screw into the shaft. The brass pad's doing it. Just turn it across, move your saddle up and down so it engages, and then just tighten the grub screw. You don't need any pressure or anything, just do it gently. In fact, it's better that there's not a lot of pressure on this, because you're forcing the gear into the lead screw. Let it locate itself. You see it goes round, and you'll engage when you get to the mark. A is the position that you can use all the time for any thread, but then if you're using a finer thread or a coarser thread, you can use the other positions depending on which gear you're selected. And there's a chart on the internet, I'll put the website address, where you can get the original Boxford chart, which gives you the pitch of the thread that you're cutting, which gear you should use, and which positions on the thread dial you can use. Wait for A to come round. Just stop it so that the backlash is all out and it's pushing the saddle along, and that's the marker position. You'll see if I move forward or backwards, there's a little bit of play in there. So all I'm going to do, marker pen, and I'm just going to put a mark with the A's, disengage, let it go around again, and you'll see I can engage it in that position there, which is too far over. That position there. So I'll just mark that there, or that position there. So you've two marks where you could be. There or there, and obviously between the two is the 3mm pitch on your lead screw. So once you've marked the position, I'll use that one. We need to make the datum mark. For the datum, a piece of aluminium, put a line on the top. I've drilled 2 holes in, ready for some rivets. All I'm going to do is line that up with the A, mark the position of the holes, rivet that to the body. Here's a finished thread dial indicator. By the way, they don't all work with the one gear. Some of them will line up and some won't. So when you change the gear, use different letters. So that's it. I'll just take that out and show you. There's the marker on the top. Lines up with the datum. And that was just riveted on through two, we can't see them now, through 2 holes in the side. If I get the light right, you might see the holes or the rivets. That's the finished item. Here's a sketch of the part. You can pause the video or take a screenshot to get the information. So now comes the time to test whether the gear indicator works. And what I've decided to do is take 2 screw pitches, 4mm and 3.5, and the reason for that is they use the different gears, and they use A and D and A and E, so they use the different letters. All of them use A. So on this chart it gives you the screw pitch in millimeters, the gear 1 or 2, 1 being the 20 teeth, 2 being the 21 teeth, and the letters that will be used for that gear. I'm cutting a 4mm pitch, and what I've done is just put a piece of plastic tube in there, because obviously I don't want to cut a real thread. It'll take time to set up a threading tool and get some steel and everything, so I've just put a plastic tube in. In the tool holder I've put pencil, repelling pencil. What I aim to do is start the machine off. So I put the pencil in to get a mark, starting mark, here we go. And I'll engage this when it comes to A. See, it's the plastic tube's running out a bit, but it is marking where the thread should be. I'll disengage, wind it back to the beginning, try and line it up with the pencil line. Then I'll start the machine and engage it on E. So we start the lathe again. It's E, well there are two E's, so I'll take the first E, I'll stop the lathe, I'll stop the lead screw so it's out of sequence and wait for the next E to come round. Now, see, I'll try this one. Now, that should still be back on the same. This is my starting mark. I went along with A, came back, restarted with E, stopped here and then started again, and you can see there's no extra marks, it's still the same mark. So I think that's proved that using the letters on the chart it is in the same position. So I've changed the gear ratio now. I'm cutting a 3.5mm pitch. I've changed the gear on the end of the thread dial to the 21 tooth. And now I should line up with A and D. Move it back. Start off on D on this one. Stop it again. Disconnect the gears, bring it back, now we'll start off on the other D. see that's still in line. Still in line with the first cut. So I'm happy with that. The two gears work on two different pitches and they both stay in line. Oh well, that's it for today. Hope that was interesting. I hope it was useful. And if you liked it, why not subscribe? And we'll see you next time on Enots Engineering.